There is a place at the center of everything we know, a place so warm and so constant that we have built our entire sense of time around its slow turning in the sky. It is not a place you could ever visit. Not really, not in any ordinary sense of the word. And yet, in a way, we are always close to it. Always held gently in its reach. Always quietly aware of it, even on the coldest and cloudiest of days. It is the sun, our sun. And it has been burning in that same broad corner of the galaxy for longer than the mind can comfortably hold. Something like 4.5 billion years. A number so large it becomes almost meaningless. Almost dreamlike, and perhaps that is the right way to receive it. Not as a fact to be pinned down and measured, but as a feeling, the feeling of something ancient and patient and endlessly generous with its light. Imagine, if you will, standing somewhere very far from any city. Somewhere out in open country where the horizon is wide and unobstructed, and watching the sun go down on a clear autumn evening. The light at that hour is thick and golden, almost like something you could touch, almost like warm honey poured slowly across the fields and the rooftops and the tops of the trees. The air carries the smell of dry grass and cooling earth. And somewhere nearby there is the faint sound of wind moving through leaves. A soft rustling, unhurried and easy. The sun at that moment does not look like a furnace. It does not look like anything dangerous or overwhelming. It looks like a hearth. It looks like the oldest and most reliable hearth in the world, settling down for the evening, sending its last warmth across the land before it rests below the edge of things. That image of the sun as hearth is one that human beings have carried with them for as long as there have been human beings to carry anything at all. Long before anyone had words for what the sun actually was. Long before the first careful observer thought to track its path across the seasons. People felt its warmth on their skin and understood, in the most immediate and bodily way, that it was the source of something essential. Warmth, light, the growing of food. The difference between a day when work was possible and a night when rest was necessary. The sun organized life. It gave shape to the hours and the seasons and the years. And in doing so, it gave shape to everything else. To the planting of crops, to the timing of festivals, to the way a farmer knew when to expect the first frost and when to expect the first green shoots pushing up through the softened ground. In the very earliest human settlements, the ones we know only through the patient work of archaeologists brushing soil away from stones and bones, and the faint outlines of ancient fires. The sun was already a presence that people oriented themselves toward. Not just physically, not just in the way that a plant turns its face toward the light, but spiritually, architecturally, in the very way they arranged their lives and their sacred spaces. There are places in the world, old places where stones were set upright in careful alignment, so that on one particular morning each year, the light of the rising sun would fall in exactly one particular way, through a narrow gap across a stone floor, illuminating something that had been placed there deliberately to receive it. These alignments took generations to plan and build, and they speak to something very deep in the human relationship with that distant warmth. A desire to be in conversation with it. A desire to mark the moment when the sun reached its farthest point south and began, slowly and imperceptibly, to return. The return of the sun. That phrase alone carries so much feeling in it. So much quiet relief, the winter solstice. that shortest day somewhere around the middle of December in the northern half of the world, has been a moment of significance in culture after culture, in place after place, across thousands of years of recorded and unrecorded human experience. Not because anything dramatic happened on that day, but because of what it promised. From that day forward, the light would begin to lengthen again. Only by seconds at first, barely noticeable, but the direction had changed. The sun was coming back. And in the days before electric light, before the reliable warmth of central heating, before the grocery store made the harvest season irrelevant to daily survival, that promise mattered enormously. It was the kind of promise you would celebrate with fire and food and the company of everyone you loved, gathered close together in whatever shelter you had built against the cold. It is a beautiful thing to consider, this long human habit of paying attention to the sun. Not just using it, but watching it, honoring it, building monuments and calendars and whole systems of meaning around its movements. The ancient Egyptians understood the sun's yearly journey with remarkable precision, and they wove that understanding into their architecture, their agriculture, their sense of the divine. In Egypt, the sun was not merely useful. It was Ra, the great mover, the one who sailed across the sky each day in a boat of light and descended each evening into the western horizon to travel through the underworld and emerge again. Renewed in the east, the image is poetic, and it is also, in its own way, a kind of science. An attempt to explain the regularity of something that seemed, to the watching eye, almost too reliable to be natural. The sun always rose, the sun always set. Something must be tending it. Something must be responsible for that extraordinary consistency. And consistency really is one of the sun's most remarkable qualities, though we rarely stop to appreciate it. We take it for granted, as we take for granted all the things that have always been there. But the sun has been burning at roughly the same brightness, radiating roughly the same warmth, for billions of years, not perfectly constant. There are slow cycles, gentle variations, subtle pulses in its activity, but broadly, steadily, it has maintained the conditions necessary for liquid water to exist on this small planet, for the chemistry of life to proceed, for all the extraordinary variety of living things that have ever existed here to find their footing and flourish, and eventually, in one remarkable case, to look back up at the source of their warmth and begin to wonder what it actually was. What it actually is, in the most straightforward terms, is an enormous sphere of gas, mostly hydrogen with a good deal of helium and smaller amounts of everything else, held together by its own gravity and generating energy through a process that happens deep in its core. The temperatures at the center of the sun are so extreme, the pressures so immense that hydrogen atoms are pressed together until they fuse, combining to form helium and releasing, in the process, an almost incomprehensible amount of energy. This energy works its way outward from the core slowly, extraordinarily slowly, bouncing and scattering through dense layers of solar material, taking thousands of years to travel from the center to the surface. And then, once it reaches the surface, it travels the remaining distance to us, about 93 million miles, in just 8 minutes. 8 quiet minutes of travel through the emptiness of space. And then it is here, warming your face, lighting the page of a book, making the shadows of leaves dance on a garden wall. The surface of the sun, if you could somehow observe it from a safe and comfortable distance, would look nothing like the smooth golden disk we see from Earth. It would look alive, turbulent in a slow and churning way, covered in a constant gentle boiling of plasma, that fourth state of matter, beyond solid and liquid and gas, a hot soup of charged particles that behaves in ways both beautiful and strange. Across this surface you would see granules, each one roughly the size of a small country, rising and falling as hotter material wells up from below, releases its energy, cools slightly, and sinks back down, only to be replaced by more rising material from beneath. The whole surface shimmers and shifts in this way, a slow and endless convection, like the surface of a very gently simmering pot of something thick and golden. Here and there across that shimmering surface, you would notice darker patches. Not dark in any absolute sense, but cooler than their surroundings, and so appearing darker by contrast. These are sunspots, regions where the sun's magnetic field has tangled and concentrated in ways that temporarily suppress the rising of hot material from below. Sunspots come and go over a cycle of roughly 11 years, growing more numerous and then fading back again in a slow rhythm that has been observed and recorded for centuries. Chinese astronomers were noting sunspots more than 2,000 years ago, watching them with careful eyes and recording what they saw, adding their observations to the long human conversation with the sun that had been going on since the very beginning of recorded thought. And then there is the corona, the sun's outer atmosphere, which extends far beyond the visible surface into the space around it. The corona is one of the most beautiful things in the natural world, and it is something most of us will never see with our own eyes, except in the extraordinary circumstance of a total solar eclipse, when the moon passes directly between the Earth and the sun and covers that bright disk completely, revealing the pearly, feathery halo of light that surrounds it. People who have seen a total solar eclipse often describe a feeling of profound stillness in that moment. The temperature dropping, the birds going quiet, the sky turning a deep twilight blue in the middle of the day, and there above you the sun's hidden crown revealed, streaming outward in long delicate rays like the petals of some enormous flower made of light. It is the kind of sight that stays with a person forever, quiet and indelible. The corona is also the source of what is called the solar wind, a constant gentle stream of charged particles flowing outward from the sun in all directions, filling the entire solar system with a kind of invisible breath. This solar wind reaches every planet, every moon, every comet and asteroid in our solar neighborhood. It shapes the tails of comets, always pointing away from the sun no matter which direction the comet is traveling. It interacts with the magnetic fields of planets to create auroras, those soft curtains of green and pink and violet light that shimmer in the polar skies on clear winter nights. One of the most quietly magical things our world has to offer. The northern lights are, in a sense, the sun touching the earth in a very gentle way, its outstretched breath brushing against our magnetic field and setting the upper atmosphere softly glowing. There is something deeply comforting in the thought that the sun is not merely a distant object we orbit, but something we are always in contact with, always receiving from. Its light warms us, its wind reaches us, its gravity holds us in our path. We are not separate from the sun in any meaningful sense. We are part of its extended family, shaped by it, sustained by it. made in large part from the same material that makes up its outer layers. The iron in your blood, the calcium in your bones, the oxygen you are breathing right now. These elements were forged in stars, in the hearts of suns that lived and ended long before our own sun was born. And the debris of those ancient stellar lives drifted together over millions of years to form the cloud of gas and dust from which our solar system condensed. The sun and the earth and everything on the earth, including you, grew from the same beginning. That is not a metaphor. It is simply what happened. Perhaps that is why, across so many different cultures and so many different centuries, the sun has felt like something more than just a light in the sky. Something closer, something almost familial. The ancient Romans spoke of Sol Invictus, the unconquered sun, and built temples to it and held festivals in its honor in the depths of winter. The Inca of South America called the sun in Thai and considered themselves his children, building their great city of Cusco as a sacred center from which the sun's influence radiated outward across the land. The Japanese imperial family traces its divine ancestry to Amaterasu, the sun goddess whose name means something like the great divinity illuminating heaven. In culture after culture, the sun is not merely observed but loved, treated as a parent, a ruler, a source of life that deserves gratitude and attention and care. And now, in our own time, we have sent our instruments close to the sun in ways that would have seemed like pure fantasy to any of those earlier worshippers and watchers. A spacecraft called Parker Solar Probe has traveled closer to the sun than anything human-made has ever gone before, skimming through the outer corona, tasting the solar wind at its source, measuring and recording and sending back information that scientists are still working to fully understand. It travels at extraordinary speeds, protected by a heat shield that keeps its instruments cool even as the environment around it reaches temperatures that would vaporize almost anything. And yet even this remarkable machine, even this triumph of engineering and curiosity, is simply continuing the oldest human tradition. The tradition of watching the sun, paying attention to it, trying to understand what it is and what it means and how it works. What it means in the end may be simpler than all the science and all the mythology combined. It means warmth, it means light. It means the slow turning of the seasons and the reliable return of spring. It means the golden hour at the end of a long day, when the light comes in low and everything it touches looks briefly like something precious. It means the way a sunny afternoon in early March, when the air is still cold but the light has changed, can make a person feel, without quite knowing why, that everything is going to be all right. We will leave the sun now, gently, the way you leave a fire when the evening has grown late and it is time to find your bed. We carry its warmth with us as we go, out into the cooler reaches of the solar system, where the light grows a little thinner and the distances between things grow a little wider. Our first stop is not far, just the nearest world inward, the small and stony planet that circles closest to the sun, keeping its ancient vigil in the heat and the brightness. But that is a story for a little further on. For now, let the warmth of the sun settle around you like a blanket, and rest. So we begin to drift, very slowly outward from that great warmth, the way a leaf might ease itself away from a fire on a still evening. Not in any hurry, not pulled by anything urgent, simply moving in the gentle, unhurried way that all things in this solar system seem to move when you give them enough time to find their rhythm. The first world we come to is small, and old and quietly remarkable in the way that very old things often are. Mercury, even the name, has a softness to it when you say it slowly, the syllables rolling forward like a smooth stone across a wooden floor. Mercury, it sits closer to the sun than any other planet, close enough that if you were standing on its surface at the right moment, the sun above you would appear nearly 3 times as wide as it does from where you are right now. Enormous and golden and filling a great portion of the sky. And yet, for all that nearness, Mercury is not the hottest world in our solar system. That is one of its quiet surprises, one of the gentle contradictions it holds without any fuss. Because Mercury has almost no atmosphere to speak of, just the faintest whisper of gases clinging to it, too thin to be called air in any real sense, too thin to hold warmth the way a coat holds warmth against a winter evening. So the heat from the sun arrives in full, blazing force during the long Mercurian day. And then, when that side of the planet turns slowly away into shadow, the warmth simply leaves. It drifts off into the darkness of space with nothing to hold it back. The temperature drops in a way that is almost difficult to imagine. From hot enough to soft and light, down to cold that would make the deepest winter night on Earth feel almost mild. Imagine, if you will, a landscape of pale gray and dusty brown. Ancient rock worn smooth in places by billions of years of quiet stillness. There is no wind on Mercury worth speaking of. No rain, no weather of any kind to reshape the surface or carry seeds or wear down the edges of things. What is there has simply been there, largely undisturbed for an almost incomprehensible span of time. The craters you would see stretching across its surface were made long ago in the early days of the solar system, when smaller rocks and pieces of debris were still finding their orbits, still settling into the slow dance that everything now follows so reliably. Those craters have just stayed there ever since, holding their shape the way an impression stays in soft clay after it has hardened. One of the largest of these craters has a name that suits it rather beautifully. The Caloris Basin. It is an enormous shallow bowl in the rock, wide enough that if you placed it over parts of a continent, it would cover them entirely. Scientists believe it was made by a very large impact in those early, unsettled times, and around its edges, the ground is wrinkled and ridged in long, gentle waves like the surface of water after something has been dropped into it. Except these waves are made of rock, and they have been frozen in that position for so long that the number of years involved starts to feel more like a kind of poetry than an actual measurement. Mercury turns very slowly on its axis, much more slowly than Earth does. Its day, the time it takes to rotate once, is longer than its year in a certain sense, which sounds like a riddle but is simply one of those quiet, interesting facts that the solar system offers up without ceremony. It moves quickly in its orbit around the sun, tracing that ellipse with a brisk efficiency, while simultaneously turning so gradually that the sun appears to crawl across its sky at a pace that would make even the most patient observer settle in for a very long wait. There is something deeply restful about Mercury. In its way, it asks nothing of you. It makes no noise, it simply sits there in the inner solar system, ancient and gray and unhurried, its surface holding the memory of ancient impacts the way old wood holds the marks of everything that has ever rested against it. Spacecraft have visited Mercury, have photographed its gray plains and its wrinkled ridges and its shadowed craters. And each image that came back had that quality of great antiquity. A world that has been sitting quietly for longer than the mind can comfortably hold. Doing very little, changing almost not at all. In the permanently shadowed craters near Mercury's poles, where sunlight never reaches because of the angle of the planet and the depth of the crater walls, scientists have found evidence of water ice. Water ice on the planet closest to the sun. It sits there in the cold and the dark, tucked into those shadowed hollows like something carefully set aside and forgotten, preserved perfectly by the simple fact that the light never touches it. There is something almost tender about that image, something that feels like a small, quiet gift the planet is keeping in its pocket. And so we leave Mercury to its stillness, to its long, slow turning and its pale gray plains and its ancient craters. And we drift a little further outward, the sun growing very slightly smaller behind us as we go. And we come to the second planet, the one that glows so beautifully in the evening sky that people have been watching it for as long as people have watched the sky at all. Venus. It is the brightest object in the night sky after the moon, bright enough on a clear evening to cast a faint shadow, bright enough that you might notice it without even meaning to. A steady cream-colored point of light sitting low on the horizon after sunset or just before sunrise, depending on the time of year. Ancient observers gave it two names because they thought it was two separate objects: the evening star and the morning star, not realizing until much later that both were the same world, simply appearing at different times as it moved through its orbit. There is something lovely about that misunderstanding, something that speaks to how carefully people have always looked at the sky, even without the tools to fully understand what they were seeing. They noticed, they kept records. They gave it names and wove it into stories. And the planet shone on, indifferent and beautiful, wrapped in its thick blanket of cloud. Those clouds are part of what makes Venus so bright. They cover the planet completely, an unbroken layer of pale yellowish white that reflects sunlight back into space with extraordinary efficiency. From a distance, from the darkness of space, Venus looks almost luminous, smooth and creamy and serene, like a pearl resting in velvet. It is easy to understand why early astronomers and dreamers imagined it as a kind of twin to Earth. Perhaps a warmer, gentler version, perhaps covered in lush vegetation or warm, shallow seas. The reality, as spacecraft eventually revealed, is quite different, though it has its own strange kind of grandeur. Those beautiful clouds are made largely of sulfuric acid droplets, and beneath them the atmosphere is enormously thick and heavy, pressing down on the surface with a weight that is roughly 90 times what you feel standing in the open air on Earth. The temperature at the surface of Venus is around 460 degrees Celsius. Give or take, and it stays that way all the time. Day and night at the poles and at the equator. Because that thick atmosphere traps heat so thoroughly that it has nowhere to go. This is the greenhouse effect carried to its fullest expression. The warmth held so completely that the planet has settled into a deep, steady heat that has persisted for an enormously long time. The Soviet space program, in the middle decades of the 20th century, sent a series of spacecraft to Venus. probes that descended through those clouds and eventually reached the surface. Most of them survived for only a short time before the heat and pressure overwhelmed them. But some sent back images and data in those brief windows. And what they showed was a landscape of flat volcanic plains, of rocks worn smooth and dark, lit by a dim orangish light that filtered down through the thick atmosphere from the hidden sun above. Imagine standing in a very thick fog, one that had a faint amber color to it. The light diffused and even from every direction. No shadows, no direct sunlight. Just that soft and pervasive glow. The ground would be warm beneath your feet in a way that went beyond warmth into something else entirely. And the air, if you could call it air, would press in from every side with a weight that felt almost solid. Those spacecraft, the Venera probes as they were called, were remarkable pieces of engineering, built to withstand conditions that engineers had to imagine before they had ever been measured. They were designed with great care and sent on long journeys across the inner solar system. And the ones that reached the surface and transmitted even a few minutes of data before going silent were considered a genuine success. There is something quietly moving about that. The effort and patience that went into building something to survive even briefly in a place so inhospitable. Just to know what it looked like. Just to satisfy that deep human desire to see. Venus rotates in the opposite direction to most of the other planets. If you could stand on its surface and the clouds parted long enough to see the sun, it would rise in the west and set in the east, moving slowly across the sky in a direction opposite to what you are used to. And it rotates very slowly, so slowly that a Venusian day is longer than a Venusian year. There is that quality again, that same unhurried turning that Mercury also has, as though the inner planets have decided that time is not something to be rushed through. The surface of Venus, beneath all that cloud and heat and pressure, is shaped largely by volcanic activity. There are vast plains of solidified lava, and volcanic mountains and long winding channels that may have been carved by ancient lava flows moving across the landscape over enormous spans of time. There are features called coronae, roughly circular formations in the crust where hot material from deep inside the planet has pushed upward and then subsided, leaving a kind of wrinkled ring in the rock. And there are highland regions, elevated plateaus that rise above the plains the way a table rises above the floor. Their surfaces mapped by radar from spacecraft orbiting high above the clouds. One of the most detailed maps of Venus was made by a spacecraft called Magellan, which spent several years in orbit around the planet in the early 1990s, using radar to peer through the clouds and build up a picture of the surface below. The images that came from that mission showed a world of considerable geological complexity, a surface that had been shaped and reshaped by the heat from within, marked by features that had no exact equivalent on Earth, but that still felt somehow familiar in their broad outlines. Mountains, valleys, plains, the evidence of forces moving slowly through rock over time. There is a kind of wistfulness that comes with thinking about Venus, perhaps because it sits so close to where conditions might have been gentler, and perhaps because those early imaginings of it as a lush twin world were so appealing. But Venus as it is has its own quiet dignity. It has been doing what it does for billions of years without any need for our approval or our imagination. It sits there in the inner solar system, brilliant and cloud-wrapped and thoroughly itself, turning slowly in the wrong direction, holding its heat, reflecting the sunlight back toward us in that beautiful steady glow that has guided travelers and inspired poets, and given the evening sky its brightest point of light for as long as there have been eyes to notice it. The light of Venus on a clear evening has a quality that is hard to describe precisely. It does not twinkle the way distant stars do, because it is close enough that it presents a tiny disk rather than a pure point. And that steadiness gives it a kind of calm authority. It simply shines evenly and without flickering. A warm cream-colored light sitting just above the horizon, where the sky is still faintly colored by the departed sun. People have stopped what they were doing to look at it for thousands of years, standing in fields or on rooftops or in doorways, pausing in the middle of an ordinary evening to notice that light and feel. Perhaps something like wonder at a thing they could see but not yet fully know. And there is something in that, in the long human habit of looking up and noticing. That feels very much like the same impulse that eventually sent spacecraft out to look more closely, to descend through those clouds and touch that ancient volcanic ground. Even briefly, even knowing the instruments would not last long. The looking and the wondering are the same thing, really separated only by the tools available and the centuries between them. We have visited two worlds now, two quiet neighbors in the inner solar system, each with its own character and its own long history written in rock and heat and cloud. Mercury small and gray and ancient, holding its water ice in shadowed pockets and its memories of early impacts in its still and windless plains. Venus, brilliant and cloud-wrapped, warm beyond imagining at its surface, but so beautiful from a distance that it has always looked like something to be wished upon. Both of them have been turning in their slow orbits for longer than the mind can easily hold. And both of them will go on turning long after our brief moment of looking and wondering has passed. There is something restful in that thought, the long, unhurried continuity of it all. The way the solar system simply continues, patient and vast and indifferent to hurry. Let that thought settle around you now. The image of those two worlds moving through the dark in their slow ellipses. The sun behind us growing gradually smaller as we prepare to drift a little further outward still, toward the blue and green world that comes next, the one that is in all the solar system, the one we know best of all. And so we arrive here, to this small and luminous place, suspended in the dark like a lantern left burning in a very large room. From a distance, from the kind of distance that makes the mind go quiet, the earth is mostly blue. Not the sharp, declarative blue of a painted wall or a summer flag, but something softer than that, something that shifts and breathes. It is the blue of shallow water over pale sand, deepening gradually toward the center, lightening again at the edges where the atmosphere catches the sun and holds it gently. The way a glass of water holds a little light on a bright morning and throws it, trembling onto the table beside it. Imagine drifting far enough away that the whole planet fits comfortably in your field of view. The first thing you might notice is how much of it is cloud. Great white whorls and sweeping veils of vapor, moving so slowly from this distance that they seem almost still. Almost painted there, but they are not still. They are enormous and alive, carrying moisture from one ocean to another, from the warm tropics toward the cooler poles, redistributing the warmth of the sun in long, slow spirals that take days and weeks to complete their patient journeys. From out here, all of that motion looks like stillness. It looks like peace. The oceans cover most of what you see, more than 2/3 of the surface. In fact, though you do not need to hold that number in your mind, simply notice how blue it all is, how generously the water has spread itself across the globe, filling every low place, pooling in the great basins that formed over billions of years as the crust shifted and settled and found its resting shape. The Pacific alone is wide enough that you could fit every continent inside it and still have room left over. Room for the water to stretch on undisturbed, blue and breathing all the way to the horizon of itself. And yet the land is there too. If you look, brown and tan in the dry places, the great desert belts that wrap around the middle latitudes, where the air descends and dries and the ground bakes in the long afternoons. Green in the wetter places, the deep, almost impossibly saturated green of the tropical forests, dense and dark, exhaling quietly into the air above them. White at the poles, where the ice reflects the sunlight back into space with such efficiency that it acts as a kind of mirror for the whole system, keeping things a little cooler, a little more balanced than they might otherwise be. From this distance, none of it seems complicated. It seems, in fact, remarkably simple. A round thing, blue and white, turning slowly on its axis, tilted just slightly from the vertical in a way that gives it seasons. That gives the northern forests their long golden autumns and the southern hemisphere its own quiet rhythms, offset by half a year from everything happening above the equator. That tilt is only about 23 degrees. A modest lane, the kind of angle you might rest your head at when you are almost asleep and not quite ready to let go of the day. The tilt means that right now, wherever now happens to be, one hemisphere is leaning a little toward the sun and the other is leaning gently away. The hemisphere leaning in is receiving its light at a more direct angle, warming more efficiently, stretching its days longer into the evening. The hemisphere leaning away is receiving its light at a shallower angle, the rays spreading across a wider area of ground and delivering less warmth per square foot of earth. This is all it takes to make a season. Not a change in distance from the sun. The Earth's orbit is nearly circular, nearly constant, but simply the direction of that line. That soft and ancient tilt, carrying the world through summer and winter and back again with the reliability of breathing. The orbit itself takes about 365 days to complete, which is to say it takes a year, which is to say that a year is simply the time it takes this particular planet to make one full loop around its particular star. Other planets have longer years, shorter years, years that would feel unrecognizable to us. But here, the year is this long, and it has been this long for so many millions of cycles that all of life on the surface has arranged itself around it. The migrations of birds, the flowering of plants, the fattening of seeds in autumn, the long dormancy of winter roots waiting in cold soil for the light to come back around. The moon is there too. If you look carefully, a smaller sphere, considerably smaller, pale gray and mottled, keeping its patient company at a distance of roughly 250,000 miles. That distance is close enough that the moon's gravity reaches down through all that space and tugs at the oceans, pulling them into the gentle bulge we call the tide. The tide comes in and the tide goes out, twice a day in most places, with the reliability of something that has been happening for longer than there have been creatures on the shore to notice it. The sound of it, the long exhale of water pulling back over stones, the soft percussion of a wave arriving, is one of the oldest sounds on the planet. Older than any voice, older than any wind through any forest. The moon keeps one face always toward the Earth, turning on its axis at exactly the rate it orbits, so that from the surface below it always presents the same arrangement of dark plains and pale highlands, the same face that has looked down on every night that has ever happened on this world. Ancient people gave names to the patterns they saw there. A rabbit, a woman, a man carrying a bundle of sticks. And those stories varied from culture to culture, from one side of the world to the other. But the impulse behind them was the same everywhere. The impulse to find a face in the dark. The impulse to make the night feel a little less empty, a little more like company. From farther out still, the Earth and Moon together look like a double planet. Two spheres in a slow gravitational embrace, circling their common center of gravity as they both circle the Sun. There is something companionable about it, something that makes the vast surrounding dark feel slightly less vast. They have been keeping each other's company for something like 4.5 billion years, which is a number so large it loses its meaning almost immediately. The way a very loud sound becomes silence after a moment. It is simply a very long time. Long enough that the arrangement has had time to settle into something that feels, from the outside, entirely natural and serene. The atmosphere is visible from out here as a thin, luminous haze at the edge of the planet, the place where the solid world fades into the sky. It is thinner than the skin of an apple, proportionally speaking, and yet it is the thing that makes all the rest possible. The warmth, the weather, the air that moves through lungs and through the lungs of every creature that has ever breathed. It is mostly nitrogen, quiet and unreactive, doing very little except being present, making up the bulk of the mixture. And then oxygen, about a fifth of it, which is the part that burns and sustains and keeps the fires of metabolism going in every cell of every living thing. And small amounts of other gases, including carbon dioxide, which is present in such modest quantities that you would not notice it in a room. And yet it is doing the essential work of keeping the planet warm enough to be livable, trapping just enough of the sun's heat to keep the oceans liquid, to keep the rain falling, to keep the whole intricate arrangement of life from freezing over. The weather moves through this thin shell of air with a kind of unhurried grandeur that is only visible from a distance. The great storm systems, the ones that look from space like white pinwheels slowly unwinding, are carrying energy from the warm equatorial regions toward the cooler poles, evening out the temperature differences that the sun's unequal heating creates. They are, in a sense, the planet's way of taking care of itself, of distributing warmth the way a sleeping body redistributes its heat under a blanket, finding its own equilibrium in the dark. There is something in the color of the Earth, seen from space, that is difficult to describe without reaching for the word beautiful, though that word is perhaps too small for it. The astronauts who have seen it, those few dozen people who have had the particular fortune of floating far enough away to see the whole thing at once, have described a feeling that comes over them, a feeling of recognition and tenderness, as though they were seeing something they had always known but never quite seen before. The planet looks fragile from out there, Not because it is exactly, but because the space around it is so large and so empty that anything within it begins to seem precious simply by virtue of being there at all. The light on the sunlit side is warm and clear, the kind of light that makes everything it touches look considered. Looked after. The shadow side is dark, but not entirely. The cities there, the ones that have grown up over the last century or two, glow with their own light, amber and white, tracing the shapes of coastlines and river valleys and the places where people have gathered in the greatest numbers. From space, the lit cities of the night side look like a second set of constellations, lower and warmer than the stars, more irregular, following the logic of geography rather than the vast geometry of the galaxy. The poles are white and still. The Arctic ice floating on the ocean reflects the low-angled polar sunlight back into space with a clean, almost mirror-like quality. The Antarctic ice, resting on the continent beneath it, is older and thicker, carrying within its layers a record of every atmosphere the planet has had for hundreds of thousands of years. Bubbles of ancient air trapped in the ice like small, patient archives waiting for someone to come and read them. The ice there is blue in its deep places, a blue so pure and cold that it seems to belong to a different category of color than the blue of the ocean. More interior, more compressed, the blue of something that has been still for a very long time. Down on the surface, and we can let our attention drift there for a moment. Down through the atmosphere, down through the clouds, down to where the ground begins. There is so much texture and variety that the mind could wander through it for a lifetime and not exhaust it. The smell of rain on dry earth, the sound of wind moving through tall grass in the late afternoon, the particular quality of light in a forest when the canopy is thick and the sun comes through in scattered pieces, landing on the ground in small bright pools that shift and dissolve as the leaves move. These are the textures of the world as it is lived in, as it has been lived in for as long as there have been creatures here to live. And yet from far enough away, all of that texture and variety and richness resolves into something simple. Blue and white and green and brown, turning slowly, catching the light, keeping its own quiet company in the dark. The planet does not seem to be in a hurry. It turns at its own pace, orbits at its own pace, breathes its weather in and out at its own pace. And all of the urgency that fills the lives of the creatures on its surface does not seem to reach it at that distance. It seems from out there, entirely at ease. There is a kind of comfort in that, if you let it settle. The idea that underneath all the motion and noise and complexity of a living world, there is something that turns slowly and holds its course and has been doing so for longer than any story can contain. The planet is patient in a way that nothing on its surface quite manages to be. And perhaps that patience is something that can be borrowed, at least for a moment, at least for the length of a quiet evening when the mind is beginning to loosen its grip on the day. The earth continues its turn. The terminator line, the boundary between the sunlit side and the shadow, moves across the surface at a pace you could almost walk alongside, if you were very steady and very patient. It crosses mountains and plains and the open ocean without distinction, bringing evening to one place and morning to another in the same slow, continuous motion that has been cycling since before there were eyes to see it. Somewhere on that line right now, the light is golden and low, The shadows are long, and the air has that particular quality it gets in the last hour before dark, when everything seems slightly more itself than it was an hour ago. We rest here a moment, with this quiet blue world, before our attention begins to drift outward again, carried on the same slow current that has been guiding us all along. Outward through the dark, past the orbit of the moon, past the place where the Earth's gravity finally loosens its hold and the sun's wider influence takes over, and on toward the next world in the sequence, the red and dusty one that waits at a little more distance, a little more removed from the warmth, turning in its own patient way beneath its thin and ruddy sky. And so we drift a little further still, carried gently outward on that long, slow current of space. And Mars comes into view the way a distant campfire might appear through trees. A warm russet glow, small and steady. Patient in the dark, it has been waiting there for a very long time. This fourth world from the sun, and it does not rush to meet us. It simply turns slowly in its own unhurried rhythm, and we are welcome to approach at whatever pace feels right. The first thing you might notice, drawing close, is the color. Mars is red in the way that old terracotta pots are red, or the way dry clay Earth looks in the late afternoon when the sun is low and golden. It is not a harsh or alarming red. It is a dusty, settled, ancient red, the color of something that has been sitting in the sun for a very long time and has slowly, gently oxidized into something quieter than it once was. The iron in its soil has rusted over billions of years, and the whole planet has taken on that warm ochre tone, like a piece of pottery left out in a garden through many long seasons. Imagine the surface from above, the way a slow-moving cloud might see it. Vast plains stretch in every direction, smooth in some places, rippled in others. The way a sandy beach looks after the tide has pulled back and left gentle ridges in the wet sand. The dust here is extraordinarily fine, finer than flour, finer than talcum powder. And it has been lifted and carried and set down again so many times over so many millions of years that it has settled into something almost silky. If you could run your fingers through it, it would slip away like the finest dry sand you have ever touched, leaving just a faint reddish stain on your skin. The color of old brick. The sky above that surface is not the deep black of open space, nor the rich blue of the sky we know. It is something in between, something softer, a pale butterscotch during the day, shifting toward a dusty lavender near the horizon at sunrise and sunset. The sun itself, seen from Mars, is smaller than we are used to, a little more than half the size it appears from Earth, and its light arrives softer, more diffused, the way sunlight feels on an overcast afternoon in early autumn when everything is warm but gentle and there are no hard shadows anywhere. There is wind on Mars, though the air is very thin, so thin that a breeze there, even a strong one, would barely ruffle your hair. And yet that thin air has been working steadily for an almost incomprehensible span of time, and it has shaped the landscape in ways that are unmistakable. Dunes roll across the plains in long, graceful curves, their crests sharp and clean. Some of them are dark, made of volcanic basalt sand, and they lie in contrast against the lighter russet dust around them, the way shadows lie across a sunlit floor. The wind moves these dunes, very slowly, a few centimeters each year perhaps, so that over centuries they migrate across the landscape like very slow, very patient travelers making their way from one place to another with no particular urgency. In the northern reaches of the planet, there is a great low plain, smooth and wide, that scientists have given the name Vastitas borealis. The northern wasteland, though wasteland feels too harsh a word for something so quietly beautiful. It is simply very large and very flat and very still. The way a frozen lake is still in midwinter. The way a salt flat is still in the heat of a desert afternoon. Nothing moves there except the occasional eddy of dust, rising and falling in a lazy spiral before settling back down again. The silence, if you could be there, would be profound, not an empty silence, but a full one. The kind that feels like something rather than nothing. Toward the south, the land rises. The southern hemisphere of Mars is older. More cratered, more worn, its surface a record of ancient impacts that have long since softened at their edges. The craters rounded and shallow now, like the impressions left in soft dough by a gentle hand. These old hollows hold the memory of a time when the solar system was younger and busier, when rocks and ice and debris were still finding their places, still settling into orbits, still occasionally meeting the surfaces of worlds with slow and geological patience. That era is long past now. The craters simply rest there, wearing their age comfortably the way old hills wear theirs. And then there are the volcanoes. Mars has the largest volcano in the entire solar system. A mountain so immense that it barely looks like a mountain at all from the surface. It rises so gradually, so gently, over such an enormous distance, that standing on its slopes you might not even realize you were climbing. Its name is Olympus Mons, and it is roughly the width of France, and it rises to a height nearly 3 times that of Everest, though you would never feel that height the way you feel it on a sharp, steep peak. It is more like a vast, gentle swell in the landscape, a slow breath drawn in and held, the ground rising almost imperceptibly beneath you over hundreds of kilometers before you find yourself, somehow very high indeed. The volcano is old and quiet now. It has not erupted in a very long time, perhaps tens of millions of years, perhaps longer, and its surface is smooth and undisturbed, dusted with the same fine red powder that covers everything else. At its summit there is a wide, shallow depression, a caldera where the top of the volcano has gently subsided over time. And this hollow catches the morning light in a way that makes it look, from orbit, like a soft eye looking up at the stars. There is something restful about a dormant volcano. All that energy, all that ancient heat, now simply resting beneath a blanket of dust and time. Not far from Olympus Mons, in geological terms, there is a long scar across the surface of Mars that stretches for thousands of kilometers. A canyon system called Valles Marineris, which translates gently as the Valleys of the Mariner, named for the spacecraft that first revealed it to us. This is not a canyon carved by a river, the way the Grand Canyon was shaped by the patient work of the Colorado. It was formed by the crust of Mars pulling apart, stretching and cracking along ancient fault lines over millions of years, the way bread dough splits when it is stretched too far. The result is something enormous and yet, from the right distance, almost graceful, a long sinuous groove in the red land, its walls layered in bands of color, rust and ochre and pale gold, the way sedimentary rock walls are layered in the American Southwest. The walls of Valles Marineris catch the light differently at different times of day. In the early morning, the eastern walls are bright and warm, while the canyon floor below is still in deep shadow. And the contrast makes the whole thing look almost like a painting. Those warm, illuminated cliffs above, that soft darkness below, a slow, gradual brightening as the sun moves and the light descends. By midday, everything is equally lit, equally warm, equally still, and in the evening the western walls hold the last of the light while the rest of the world goes dark, glowing amber and rose for a little while before the cold and the dark settle in together. It does get cold on Mars. Very cold, especially at night, especially in winter near the poles. The thin atmosphere holds very little heat, and when the sun goes down, the temperature drops quickly and deeply, the way it does in a high desert on Earth. That familiar desert quality of burning days and freezing nights. The land giving back its warmth to the sky almost as fast as it receives it. At the poles in winter, the carbon dioxide in the thin air actually freezes and falls as a kind of dry snow, settling over the polar caps in a pale layer that will sublimate away again when spring comes, turning back to gas without passing through liquid, disappearing quietly into the air. The polar caps themselves are beautiful in their own understated way. The northern cap is largely water ice, ancient and permanent at its core, covered in winter by that seasonal dusting of carbon dioxide frost. Seen from above, it looks like a swirl of cream, layered and striated, the ice carved by wind and sublimation into terraced spirals that wind outward from the pole in long, gentle curves. Scientists who study these layers can read in them something like a record of Martian seasons going back millions of years, the way you might read the rings of a very old tree, each layer a quiet chapter in a very long story. There is something in the Martian landscape that feels familiar and unfamiliar at the same time. The deserts of Mars are not entirely unlike the deserts of the American Southwest, or the Atacama or the Gobi, wide and open and colored in warm earth tones, shaped by wind, crossed by dunes, lying still under a wide sky. And yet everything is slightly off, slightly different in a way that is hard to name. The sky is the wrong color. The shadows fall at the wrong angle. The sun is the wrong size. It is like a dream of a desert, recognizable in its shapes and textures, but somehow displaced, somewhere slightly other than where you expected to find yourself. The moons of Mars are small and dark and irregular, more like captured asteroids than the smooth, round moon we know. Phobos, the larger of the two, is lumpy and pitted, covered in the same fine dust as the planet below, and it orbits so close to Mars and so quickly that it rises in the west and sets in the east, crossing the sky in just a few hours. Deimos, the smaller moon, is even more modest, a tiny dark shape moving slowly among the stars, barely distinguishable from them at a glance, easy to overlook, easy to mistake for just another point of light. There is something endearing about these small, irregular moons, tumbling quietly in their orbits, unremarkable and unhurried. Scientists have sent many visitors to Mars over the decades. Small rovers that have trundled across the surface at a gentle walking pace, their wheels leaving tracks in the dust that will persist for a very long time in that windless, changeless landscape. These rovers have taken photographs and measured temperatures and analyzed the chemistry of rocks and soil. And they have sent all of this information home across the long distance between the planets. A distance that light itself takes between 3 and 22 minutes to cross, depending on where the two planets happen to be in their orbits. There is something quietly moving about the thought of these small machines, working patiently in the cold and the silence, sending their findings home across all that space. One of those rovers, a small one called Opportunity, was designed to operate for perhaps 3 months and ended up working for nearly 15 years, rolling slowly across the Martian plains, examining rocks, climbing gentle slopes, pausing at the edges of craters to look down into their shadowed interiors. It traveled in total about 45 kilometers, a modest distance, the kind of distance you might walk in a long weekend. And then one day a great dust storm covered the planet, and the rover's solar panels could no longer gather enough light. And it went quiet, its last transmission, as scientists interpreted it, contained a measurement of low battery power and a note about the darkness. And then it simply rested where it was, in the dust, in the silence, on that wide red plain. There is no drama in that ending, only a kind of peacefulness. The rover is still there, of course, sitting where it stopped, slowly being covered by the same fine dust that covers everything else on Mars, becoming in its own small way a part of the landscape. 100 years from now, 1,000 years from now, it will still be there, patient and still, the way all things on Mars seem patient and still. And that stillness is perhaps the deepest quality of Mars, the thing that lingers after all the details of craters and canyons and volcanoes have settled into the background. It is a still world, a quiet world, a world that has been doing what it does for 4.5 billion years without any particular hurry, letting the wind move its dust and the seasons frost its poles and the sun cross its butterscotch sky day after day after day. There is something restful in that continuity, something that invites you to let your own thoughts slow down and spread out. The way dust spreads across a wide plain, settling gently into every hollow and crease. We leave Mars as we found it, turning slowly, glowing that soft, warm red in the dark, its great volcano rising in a long, patient swell, its canyon catching the last of the evening light. And as we drift outward again, away from its thin atmosphere and its cold nights and its silky dust, we carry with us the feeling of that wide open stillness, that ancient unhurried quiet, and we let it settle over us like something warm and soft and light. Further out, the sun grows a little smaller still, and the distances between things begin to grow in ways that are harder to hold in the mind. And the next world we will come to is very different from anything we have visited so far. Larger, stranger, wrapped in clouds and cold. A world of a different kind entirely, waiting for us in the gentle dark ahead. And so we drift a little further now, carried gently outward on that long, slow current that has been guiding us all along, past the warm glow of the inner worlds, past the rust-colored plains and the soft polar frosts, and into a region of space that feels, at first, like a kind of in-between place, a threshold perhaps between what we have known and what is still to come. This is the asteroid belt. And already, before we have truly arrived, Something about it feels different from everything we have passed through so far. It is not a world in the way that Mars was a world, or Venus or the Earth with its blue and breathing skies. It is more like a neighborhood. A long, wide, gently scattered neighborhood of rocks and dust and ancient metal, spread across a ring so vast that the distances between its residents are almost impossible to hold in the mind all at once. You might imagine a crowd of people spread across an entire continent, each one standing quietly in their own field, separated from the nearest neighbor by miles and miles of open grass. That is something like the asteroid belt, full in its way and yet so wonderfully, peacefully empty. The light out here is already softer than it was closer to the sun. It arrives after a longer journey, traveling those extra millions of miles with a patience that seems almost deliberate. And when it finally touches the surface of a tumbling rock or a dusty, potato-shaped little body drifting in its slow orbit, the light falls at an angle that makes everything look ancient and unhurried. Shadows are long and gentle here. The sun, if you were somehow floating out among these rocks and turned to look back toward it, would appear smaller than it does from Earth. Still bright, still the undeniable center of everything, but reduced to something more like a very brilliant star. A warm point of light rather than the great blazing presence it seems from a summer afternoon on a garden lawn. There is a kind of stillness in imagining it. The asteroid belt sits in the space between Mars and the next great world outward, and it has been there for an enormously long time, since the very early days of the solar system, when everything was still finding its shape, when dust and gas and rock were slowly gathering themselves into the planets we know today. Most of what is in the belt is material that never quite managed to come together into a single planet. The gravity of the enormous world just beyond, the great giant we will visit in our own good time, stirred things up just enough, over billions and billions of years, that the rocks and metals and icy fragments out here stayed scattered, stayed individual, stayed themselves, and in a way, that is a lovely thing. Because of that gentle stirring, that patient refusal to consolidate, we have this quiet archive of the solar system's earliest ingredients, preserved in the cold and the dark, drifting along in their slow orbits like letters in a very old library that no one has quite gotten around to reading yet. There are hundreds of thousands of them, perhaps millions if you count the smallest fragments, the grains and pebbles and chips of rock no bigger than a fist. And yet, as we said, the belt is mostly space. If you were to gather every single piece of material in the entire asteroid belt and press it all together into one body, the result would be something smaller than our own moon. Smaller, quieter, a modest little world by any measure. The belt sounds crowded when described in numbers, but in the actual experience of drifting through it, it would feel more like sailing a very wide, very calm sea on a clear night, with the occasional dark shape passing at a great distance, barely visible, barely there. Some of those shapes have names now, names given to them by the people who first spotted them through telescopes on quiet observatory nights, squinting at the sky with careful patience, noting the slow movement of a point of light against the fixed background of the stars. The first of them to be discovered was found in the very first hours of a new year, more than 2 centuries ago, by an astronomer in Sicily who had been methodically cataloging the sky and noticed something that did not quite belong among the stars he had been watching. He called it Ceres, and Ceres remains, even now, the largest single body in the entire asteroid belt. So large, in fact, and so nearly round, that it has been given a special classification of its own. A dwarf planet, a small world that managed to gather itself into something approaching a sphere under the gentle pull of its own gravity. Ceres is a quiet, gray-brown world. Dusted with ancient minerals, its surface marked by craters that accumulated over billions of years of slow collisions. Not violent catastrophes we might imagine, but the long, patient accumulation of small encounters. The way a wooden table in an old farmhouse collects its nicks and scratches over generations of ordinary use. There are bright spots on Ceres, places where reflective salts have been left behind by water that once moved beneath the surface and slowly evaporated away into the thin cold of space. Those bright spots catch the distant sunlight and throw it back. And from certain angles in certain conditions, they glow like small, calm lights in the dark. Not dramatic, not blazing, just quietly present. The way a candle in a window looks from the end of a long lane on a winter evening. Imagine that for a moment. If you like, a small gray world, turning slowly in the dark, and on its surface a handful of pale bright patches catching the faraway sun. Something almost like a welcome. Beyond Ceres, the belt continues its long, unhurried spread. There is Vesta, one of the larger asteroids, a world that has its own ancient story written in its surface. A deep, wide basin at its south pole, where something very large collided with it long ago, sending fragments spinning off into space, some of which eventually found their way to Earth as meteorites. When scientists examine certain meteorites in their laboratories, working carefully under bright lights with delicate instruments, they are sometimes holding a piece of Vesta in their hands, a piece of the asteroid belt that made the long journey here, that fell through our sky as a streak of light on some ordinary night, and came to rest in a desert or a field or on the surface of an ice sheet. Waiting to be found, there is something deeply calming about that thought. The way the solar system leaves little pieces of itself in unexpected places. The way distance turns out not to be quite as absolute as it first appears. The smaller asteroids come in all manner of shapes and textures. Some are dense and metallic, the cores of ancient proto-planets that formed and then broke apart in the early solar system. Their interiors exposed to the cold of space like the inside of a geode cracked open on a stone floor. If you could run your fingers along the surface of one of these metallic asteroids, you might feel something almost like iron, cool and faintly rough, with a crystalline structure that formed over millions of years of slow cooling deep inside a body that no longer exists. Others are dark and crumbly, rich in carbon, some of them containing organic molecules, the building blocks of chemistry that, under the right conditions, can become something more. These dark, dusty asteroids smell, in the imagination at least, of something ancient and mineral, like the inside of a cave, like deep earth, like time itself. Some asteroids travel in pairs, two small bodies orbiting each other as they make their slow journey around the sun, keeping each other company across the long years. Others tumble slowly as they go, rotating end over end in a gentle, unhurried spin, their surfaces cycling through long days and longer nights. The sunlight creeping across ancient rock and then retreating again. over and over in a rhythm that has been going on for longer than any mind can truly hold. There have been visitors to the asteroid belt. Of course, a spacecraft sent from Earth on long, careful journeys, arriving after years of travel to spend time in the neighborhood, to take photographs and measurements, to hover close to the surface of a small world and study it with patient instruments. One mission, called Dawn, spent years visiting first Vesta and then Ceres, drifting into orbit around each one in turn, sending back images that showed us surfaces we had only imagined before. Craters and ridges and those quiet bright spots. The texture of ancient rock under faraway sunlight. Dawn eventually ran out of the fuel it needed to keep itself oriented, and it settled into a permanent orbit around Ceres, where it remains today, circling quietly. A small human-made object in the company of a small ancient world, both of them drifting together in the long, slow dark. There is something restful in that image. Other missions have visited individual asteroids, some of them touching down with extraordinary gentleness, landing on surfaces where the gravity is so slight that a person standing there would weigh almost nothing at all, where a gentle push would send you drifting slowly upward into space. The Japanese mission Hayabusa, and later Hayabusa 2, traveled to near-Earth asteroids, cousins of the belt, rocks that have wandered a little closer to our part of the solar system, and collected tiny samples of surface material, bringing them home in small capsules that descended through our atmosphere and landed in the Australian desert. Scientists opened those capsules in clean rooms, working with the greatest care, and found inside them ancient dust, some of the oldest material in the solar system, grains that formed before the Earth existed, before any of the planets existed, back when the sun was young and the whole solar system was still deciding what it wanted to be. To hold something that old, even in a sealed container, even through layers of careful procedure, must feel like a very particular kind of quiet. The asteroid belt, for all its vastness, is also a place of great regularity. The orbits of its members follow the same gentle rules that govern everything else in the solar system. The same mathematics that keeps the planets on their paths, that brings comets arcing back toward the sun after long journeys into the outer dark. Most of the asteroids in the belt have been in very similar orbits for an enormously long time, circling the sun in a steady, unhurried procession, completing each orbit over the course of a few years. They are, in their way, as reliable as anything in the sky. The sun rises and sets on their ancient surfaces. The stars wheel slowly overhead in their long nights. The distant sun moves through its cycle of seasons that no one is there to notice, that happen anyway, that have been happening for longer than we can imagine. There is a kind of peace in that constancy, in the idea that these small, nameless rocks have been going about their slow business for billions of years, indifferent to everything, asking nothing, simply continuing. We might rest here for a moment, in this wide and quiet neighborhood. Before we move on, there is no urgency. The next great world is still a long way off, and the journey between here and there is itself a kind of experience worth settling into. The growing distance from the sun, the light growing ever so slightly dimmer, the cold deepening in that gradual, almost imperceptible way that cold deepens when you walk slowly away from a fire and do not quite notice the change until you are already a little cooler than you were. The asteroid belt will continue its slow turning long after we have passed through it, long after we have drifted on toward the great gas giant waiting in the outer dark. Ceres will keep its quiet orbit. Vesta will carry its ancient basin. The metallic fragments and the carbon-dark pebbles and the tumbling, nameless rocks will go on circling, patient and unhurried in the long rhythm that has always been their nature. And we gently move on. The sun is smaller now behind us, a bright and steady point among the stars, still warm in its way, still the center of everything, but quieter from here, more distant, more like a memory of warmth than warmth itself. Ahead, the darkness deepens just slightly, and somewhere in that deepening dark, enormous and banded and wrapped in its own complex weather, the next world waits, a world so large it contains multitudes, so old it carries its own ancient stories in its clouds and storms and the slow movement of its many moons. All of it turning, all of it drifting, all of it waiting for us in the patient way that all the great things of the solar system seem to wait. Without hurry, without need, simply present in the quiet and the cold and the long, slow turning of everything. And so we drift a little further, carried by that same unhurried momentum, out past the rust and silence of Mars, out past the scattered rubble of the asteroid belt where countless small, tumbling stones catch the sunlight and let it go again without any fuss, each one spinning slowly in its own private orbit, minding its own quiet business. We have been traveling for some time now, and the sun behind us has grown a little smaller, a little softer, its light arriving with just a touch more gentleness than it did closer in. There is something almost like a sigh in that. The way the warmth thins gradually, the way the darkness between things grows just slightly more present, more velvety, more complete. And then ahead of us, something enormous comes into view. Not suddenly, nothing out here happens suddenly. It grows the way a thought grows when you are drifting towards sleep, slowly filling more and more of your awareness until you realize it has been there for some time already. Patient and immense, simply waiting to be noticed. Jupiter, the largest world in all the solar system. A planet so vast that more than 1,300 Earths could be tucked inside it. And it would still have room. It is not a rocky place, not a world you could stand upon and feel the ground beneath your feet. It is made mostly of gas and cloud and deep, swirling atmosphere, layers upon layers of it, descending into pressures and temperatures that grow gradually more extreme the further in you go, until somewhere at the very center there may be a dense, strange core, though even that is not entirely certain. Jupiter keeps some of its secrets gently, the way old things do. What you see first, what draws the eye and holds it, are the colors imagined standing somewhere dark and quiet, perhaps a hillside far from any town, and tilting your head back to find Jupiter in the night sky through a small telescope. It is not a pinpoint of light like the stars. It has breadth, it has presence, and across its face run bands of color. Long horizontal ribbons of cream and amber and pale orange and soft brown, wrapping all the way around the planet like the rings of a very old, very beautiful tree. These bands are clouds, enormous rivers of cloud moving in opposite directions, eastward and westward in alternating streams, driven by winds that blow steadily and have been blowing for longer than human civilization has existed. And yet, for all their ferocity, seen from a distance, they look almost peaceful, almost like the gentle stripes on a worn piece of cloth, something comfortable and familiar. Somewhere in those bands, in the southern half of the planet, there is a storm. There has been a storm there for at least 350 years. Perhaps longer, perhaps much longer. Turning slowly in a great oval shape. Its clouds tinged a soft, dusty rose. It is called the Great Red Spot, and it is wider across than the entire Earth. Astronomers first noted it in the 17th century, drawing it carefully in their notebooks by candlelight. And it was there then just as it is there now. Unhurried, self-contained, a permanent feature of the landscape, the way a certain mountain is a permanent feature of a valley you have known all your life. It has changed over the centuries, grown a little smaller, shifted in shade from deep brick red to a quieter, more muted pink, but it has never gone away. It simply turns and turns, and turns in no particular rush, on no particular schedule, because Jupiter does not need a reason for its storms. They are simply part of who it is. The planet rotates faster than any other world in the solar system, completing a full day in just under 10 hours, which means that those cloud bands are being stretched and pulled by that rotation constantly, drawn out into long, smooth lines by the speed of the spin. And yet, from a distance, none of that urgency is visible. It all looks serene. It all looks like something you might find painted on the inside of a very old dome, a ceiling fresco in some quiet library, the kind of place where the light comes in golden and thick through high windows, and the air smells of old paper and dust, and the particular stillness of rooms that have held many thoughts. Now Jupiter does not travel alone. It never has around it, in their own quiet orbits, move dozens of moons, each one a world in its own right, each one carrying its own particular character, its own particular textures and temperatures and silences. There are small ones, irregular ones, dark little bodies that may once have been asteroids captured long ago by Jupiter's enormous gravity, drawn in gently and set to circling, given a home they never asked for and perhaps never minded. But 4 of Jupiter's moons are large enough and remarkable enough that they were noticed with a small telescope in the early 1600s by an Italian astronomer named Galileo, who watched them night after night from his garden and saw them move, saw them shift position around the planet, and understood that here were worlds orbiting another world, not everything circling the Earth as had long been assumed. It was a quiet revolution, made with patience and careful observation, and a little notebook filled with small, precise drawings. These 4 are called the Galilean moons, and each one is worth a moment of your attention. The closest of them to Jupiter is Io, and Io is a world of fire. Not the frightening kind of fire, not anything alarming, but a slow, geological fire, the fire of volcanoes that erupt constantly, sending plumes of sulfur high above the surface in great pale fountains that drift and settle back down again like the most unhurried snowfall you can imagine, coating the ground in layers of yellow and orange and white and red. Io is the most volcanically active body in the solar system. Its interior kept warm and restless by the constant gentle kneading of Jupiter's gravity, which stretches and squeezes the moon as it orbits. generating heat deep inside it the way you might warm your hands by pressing them together. The surface of Io is young, constantly being resurfaced by fresh lava flows. So there are almost no craters there, almost no record of ancient impacts. It is a world that is always renewing itself, always beginning again, its history written in layers of soft volcanic color that pile quietly one atop another. A little further out is Europa, and Europa is perhaps the most quietly astonishing of all Jupiter's moons. Its surface is ice, smooth and pale and crisscrossed with long reddish-brown lines, like cracks in a frozen pond seen from very high above. Imagine the color of old cream, slightly warm in tone, with those darker lines tracing across it in gentle curves and intersections. The whole surface lit by the distant sun in a way that makes it glow softly, almost like the inside of a paper lantern. Beneath that ice, kept liquid by the same gentle tidal warmth that keeps Io volcanic, there is thought to be an ocean. A real ocean of liquid water, possibly deeper than any ocean on Earth, sitting quietly in the dark beneath kilometers of ice, insulated from the cold of space, warmed from below by the moon's own interior. What might be in that ocean is not something we know, but the thought of it is a gentle one, an ocean in the dark, patient and still, going about whatever it goes about in its own unhurried way, untroubled by the vacuum above it. Further still is Ganymede, the largest moon in the solar system, larger even than the planet Mercury. A world of ancient ice and rock with a surface that shows both very old, heavily cratered terrain and younger, grooved regions where the crust was pulled apart long ago and new material welled up from below. Ganymede has its own magnetic field, a small but real one, which means that if you could stand on its surface, you would be standing inside a faint bubble of magnetism. Invisible but present, a quiet shield against the charged particles that stream out from Jupiter and the Sun. The surface of Ganymede is cold and still and very old in places, marked with the patient record of billions of years of slow geological memory. The way the grain of very old wood holds the memory of every season it grew through. And then there is Callisto, the outermost of the four, the most ancient looking of all of them, its surface dark and heavily cratered, a record of every impact it has received over the long history of the solar system. Nothing erased, nothing renewed, simply accumulated quietly over time. Callisto is a world that has changed very little, that has sat at the edge of Jupiter's family and watched and endured and remained itself. Its surface like the face of something very old and very calm, marked by experience but not troubled by it. There is a large impact basin on Callisto called Valhalla, a name borrowed from Old Norse mythology, and it spreads out from its center in a series of gentle concentric rings, like the rings that spread across still water when something drops into it, frozen in place, preserved exactly as they were when they formed, long ago in the quiet of deep time. Spacecraft have visited this part of the solar system, more than once traveling out from Earth on long, slow trajectories that took years, arriving finally at Jupiter and its moons, and sending back images and measurements that filled scientists with a particular kind of wonder. The gentle kind, the kind that does not shout but simply sits with what it has found and turns it over slowly. The Voyager probes passed through in the late 1970s, their cameras catching the cloud bands and the great red spot and the 4 large moons in photographs that have become some of the most quietly beautiful images ever made of the solar system. Later, the Galileo spacecraft spent years in orbit around Jupiter, circling again and again, patient as the moons themselves, gathering data, sending it home in a long, slow conversation with the people on Earth who were listening. There is something very human about that, about the act of sending something small and carefully made out into the enormous dark, and then listening for what it has to say, waiting for the signal to arrive, knowing that even the signal itself takes time to travel, that you are always hearing news from a little while ago, news from the distance, delivered at the speed of light but still taking its time. It is a little like the way starlight works, the way the light reaching your eyes left its source long before this moment, so that looking up at the night sky is always a kind of gentle time travel, always a looking back as well as a looking out. Jupiter sits in its place in the solar system the way a very large, very settled presence sits in a room, not demanding attention but receiving it naturally, its gravity quietly organizing the space around it, holding its moons in their orbits, influencing the paths of smaller bodies nearby, shaping the neighborhood simply by being what it is. Some astronomers believe that Jupiter has played a long, slow role in protecting the inner solar system, its gravity capturing or deflecting some of the debris that might otherwise have found its way inward, acting as a kind of gentle shepherd, though it does this without intention, without awareness, simply through the patient mathematics of mass and motion. The light out here is softer than it was closer to the sun. Jupiter receives perhaps 4% of the sunlight that falls on Earth, which means that a day on its moons, such as it is a dim and gentle thing. The sun a bright star rather than a blazing presence. The shadows long and soft. The colors muted and quiet. Imagine the light of a late winter afternoon, the kind that comes in low and golden and does not insist on itself, the kind that makes everything look a little more restful than it might otherwise. That is something like the quality of light in Jupiter's neighborhood, and it suits the place. It feels appropriate to the scale and the age and the unhurried nature of everything out here. We have spent a good while in this neighborhood now, drifting among the moons, watching the cloud bands turn, watching Io's distant volcanic plumes rise and settle, watching the pale surface of Europa glow softly in the thin sunlight. There is no need to rush away, but there is more to see, more to drift toward, and the solar system continues outward with the same patience it has always had, the same willingness to let things take as long as they take. So we will let Jupiter grow slowly smaller behind us, its banded face receding gently as we move on, its moons becoming small bright points again, indistinguishable from stars unless you know where to look and what to look for. The great red spot goes on turning. Europa's hidden ocean goes on being still and dark and full of its own quiet mystery. Ganymede holds its ancient surface up to the dim light. And Callisto, oldest looking of all, simply continues to be exactly what it has always been. Unchanged, unhurried, present in the cold and the distance. A world that has learned, over a very long time, the particular piece of simply remaining. And from that stillness, we drift a little further out, carried along by something no more forceful than a slow exhale. and we find ourselves approaching the most quietly astonishing thing in all the solar system. A planet that seems, at first, almost too beautiful to be real, as though someone had placed it there not by accident or by the grinding machinery of gravity and time, but with a kind of unhurried intention, the way a person might set a single perfect object on a shelf and then step back and simply let it be. Saturn is there ahead of us now, and even from a great distance, even before the details resolve themselves into anything recognizable. There is something about its presence that slows the breath. It sits in the darkness the way a lantern sits on a windowsill, not blazing, not demanding attention, but quietly luminous, a pale golden warmth suspended in all that surrounding cold. The planet itself is enormous. Of course, though enormousness is a word that loses its meaning quickly out here, where everything is enormous in ways the mind cannot quite hold. Saturn is a world made almost entirely of gas, of hydrogen and helium layered in great soft bands. And its surface, if you could call it that, is not a surface at all in any way we would recognize, but a gradual thickening, a deepening, a slow transition from the thin outer atmosphere down into pressures and temperatures that become, eventually, something stranger than solid ground could ever be. But it is not Saturn itself that draws the eye. Not first, not entirely. It is the rings. They encircle the planet in a flat, wide disk extending outward for hundreds of thousands of kilometers in every direction. And yet they are, in most places, astonishingly thin in the way a piece of paper is thin when you hold it up against the length of a room. From certain angles seen from far away, they seem almost like a line drawn carefully around the planet's middle. A single stroke of pale light, precise and unhurried from other angles. They open up, they spread, and you begin to understand that what you are looking at is not a solid thing at all, but a vast gathering of particles, each one moving in its own quiet orbit, each one a small and separate traveler following a path that has been laid out for it by gravity over an almost incomprehensible span of time. Imagine standing in a field on a winter morning, when the frost has settled on every blade of grass and the low sun catches it all at once, turning the whole meadow into something that glitters softly, gently, without any particular drama, just light finding ice and offering it back to the air in small, quiet pieces. The rings of Saturn have something of that quality. That sense of countless tiny things catching the distant light of the sun and returning it in a slow, collective shimmer that is somehow more beautiful for being made of so many separate, ordinary pieces. Most of what makes up the rings is ice. Water ice in particles that range from tiny grains no larger than a grain of sand to chunks the size of a house, and everything in between, pebbles and boulders and drifting clusters of frost, all of them orbiting Saturn in the same flat plane, all of them moving at speeds that would seem extraordinary if you were watching from the ground, but which feel, from a distance, perfectly serene. They have been doing this for a very long time. The rings are ancient, though astronomers are still in the gentle, ongoing process of understanding exactly how ancient. And there is something comforting in that, in the idea that even the people who study these things most carefully are still learning, still listening, still sitting with the question the way you might sit with a cup of tea and let it cool slowly in your hands without needing to drink it right away. The light that reaches Saturn from the sun is weaker than the light we know on Earth. Softer, more diffuse, arriving after a journey of nearly 9 times the distance between the Earth and the Sun. And so the rings do not blaze. They glow, they hold the light gently. The way thin clouds hold the light of the moon, diffusing it, spreading it evenly across their surface so that the whole disk seems to breathe with a faint, even luminescence. There are places where the rings are denser, where the particles have gathered more closely together, and these places appear brighter, more opaque, like the thicker parts of a piece of handmade paper held up to a window. And there are gaps, places where the rings thin out to almost nothing, where you can see the darkness of space through them as though through a gauze curtain. And these gaps have their own quiet beauty, their own sense of order, because they are not accidents but the result of the gravitational influence of Saturn's moons. Those small, steady companions pulling at the ring particles over millions of years, nudging them gently into patterns that repeat and persist and hold. One of those gaps is wide enough and clear enough that it has a name, and has had one for a long time. The Cassini division, named for an astronomer who observed it through a telescope in the 17th century. Sitting in an observatory somewhere in Europe with the smell of candle wax and old paper around him, pressing his eye to the lens on a clear, cold night and seeing for the first time that the rings were not one continuous thing but something more intricate, more layered, more patient in their arrangement than anyone had quite imagined. He could not have known what he was really seeing. He could not have known about the ice, or the moons, or the gravity that carved the gaps so carefully. But he saw the gap, and he wrote it down, and the name has remained. A small human thread connecting that quiet observatory to this extraordinary place. There is a moon called Enceladus that orbits within the region of the rings, and it is a small world, not much larger than the state of Texas if you were to spread Texas into a sphere, and it is covered entirely in ice. Smooth, white, reflective ice that makes it one of the brightest objects in the solar system, catching the distant sunlight and giving it back with an almost cheerful generosity. And beneath that ice, something remarkable and peaceful is happening. There is warmth there, generated by the flexing of the moon's interior as Saturn's gravity works on it gently. The way you might work a piece of cold wax between your fingers until it softens. That warmth has melted water beneath the ice, and that water finds its way to the surface through cracks in the southern polar region and rises up in long, slow plumes, geysers of ice crystals drifting out into space, catching the light falling back, and in falling, contributing their tiny frozen offerings to the rings themselves. Enceladus is, in its quiet way, one of the sources of the rings, adding to them particle by particle, year by year, in a process so slow and so continuous that it feels less like an event and more like breathing. The other moons of Saturn are many, dozens of them, ranging from small irregular bodies that tumbled into orbit long ago and have been there ever since, to larger, more substantial worlds with their own geologies and their own particular characters. There is Titan, the largest, wrapped in a thick orange atmosphere that is in some ways more like the early Earth's atmosphere than anything else we know of in the solar system. Titan has weather. It has clouds and rain and rivers and lakes and seas. Not of water, but of liquid methane and ethane. Hydrocarbons that pool in the low places of the landscape and reflect the hazy sky the way any lake reflects the sky above it. Imagine sitting beside one of those lakes. If you could, the light would be dim and amber tinted, filtered through all that orange haze. And the air would be cold, far colder than anywhere on Earth. And the surface of the liquid would be very still, very dark, and the silence would be the kind of silence that has no edges to it, that simply extends in every direction without interruption. It would feel perhaps like the silence just before sleep. Not empty, but full of something that does not need to be named. The Voyager spacecraft passed through the Saturn system in the early 1980s, and the images they sent back were the first time human beings had seen the rings up close, had seen the fine structure within them, the braided patterns in some of the outer rings that no one had predicted, and that took years to begin to understand. The scientists who received those images were sitting in rooms in California, watching the data arrive on screens. And there must have been a particular quality to those moments. A quietness perhaps beneath whatever excitement was present. The quietness of encountering something that has existed for far longer than you have. Something that does not know it is being observed and would continue exactly as it is, whether you were watching or not. The rings do not perform. They simply are. A spacecraft called Cassini, named, as it happened, for the same astronomer who had observed that gap through his 17th century telescope, spent 13 years orbiting Saturn, from 2004 until 2017. And in that time it sent back an extraordinary accumulation of images and measurements and observations. A slow, patient portrait of a world and its rings and its moons built up over years the way a painting is built up in layers, each one adding depth and subtlety to what came before. The images from Cassini have a quality that is difficult to describe. They are scientifically precise, captured by instruments designed to measure and record. And yet they are also, many of them, simply beautiful in the way that a long exposure photograph of the night sky is beautiful, or the way a piece of music is beautiful when it takes its time and does not rush toward its conclusion. There is one image in particular, taken when Cassini was positioned on the far side of Saturn from the Sun, so that the planet eclipsed the Sun entirely and the rings were backlit, glowing in a way they cannot be seen from Earth. In that image, Saturn sits at the center, dark and ringed in a thin crescent of light at its edges, and the rings spread out around it in concentric arcs of soft gold and pale white. And far off in the distance, almost lost in the outer rings, there is a tiny point of light, faint, almost invisible, and that point of light is Earth. It is perhaps the most quietly humbling image ever taken. Our entire world, everything that has ever happened, every person who has ever lived, rendered as a single dim pixel in the vast, serene architecture of Saturn's rings. And yet it does not feel diminishing. It feels somehow like a reminder that we are part of all of this, that we belong to the same solar system as those rings, that the same sun that warms our mornings also lights that distant, frozen shimmer. And so we linger here a little longer than we have lingered anywhere else, because there is something about Saturn that invites lingering, that does not hurry you along. The rings turn slowly in the darkness, each particle following its path with the quiet persistence of something that has been doing this for a very long time and expects to continue doing it for a very long time more. The golden light of the planet warms the inner edges of the rings just slightly, and the outer edges cool into the deeper dark, and the whole system turns together in a kind of slow, planetary breathing, and the moons move in their orbits. and Enceladus exhales its fine mist of ice crystals into the space above its southern pole. And Titan sits wrapped in its amber haze with its still, dark lakes reflecting a sky that no human eye has ever seen directly. There is a particular kind of peace that comes from watching something beautiful that does not require anything of you, that asks only that you be present, that you allow it to exist in your awareness without needing to explain it or hold it or carry it away with you. Saturn's rings have that quality. They are content to be what they are. They have been content for a very long time. We rest here in the soft golden light, in the quiet turning, in the faint shimmer of all that ice catching the distant sun. The rings breathe their slow, orbital breath. The darkness around them is not empty but full of the same patient silence that has held this place since long before there were eyes to see it, and will hold it long after. Unchanged and unhurried, a kind of stillness so deep it becomes, after a while, something very close to comfort. And when we are ready, when the rings have shown us everything they wish to show us, and the golden light has settled into something softer, something that asks us to carry it gently as we go, we will drift outward again, further from the sun into the deeper cold, toward the last of the great outer worlds, where something blue and far away is waiting for us with its own particular quiet. And so we arrive at last at Neptune. It is a long way to come. If you were to imagine the journey as a slow walk through a very large house, then the sun would be the warm hearth in the very first room, and Neptune would be somewhere out beyond the garden, beyond the fence, beyond the field that stretches away behind the fence, so far that the light from the windows of that first room has faded to something barely distinguishable from the ordinary dark. You would not be able to hear the fire from here. You would not be able to smell the wood burning. There would only be the cool, still air and the faint blue suggestion of a world hanging quietly in the distance, turning slowly on its own, as it has always done. Neptune is blue the way deep ocean water is blue, not the bright, cheerful blue of a summer sky, but something richer and more considered, a blue that seems to come from within, as though the planet itself has been thinking about that particular color for a very long time and has decided it suits. The color comes from methane in the atmosphere, which absorbs the redder wavelengths of the little sunlight that reaches this far, and lets the blue ones drift back out into space. It is a gentle kind of chemistry, the sort that happens without hurry, without fuss, in the cold and the quiet of the outer dark. The sunlight here is something worth pausing to consider. At this distance, the sun is still visible, still present, but it has become something more modest than the blazing, overwhelming presence it is from Earth. From Neptune, the sun looks like a very bright star, the brightest star in the sky by a considerable measure, but a star nonetheless, something you could look at, almost if you shielded your eyes just a little. The light it casts is real but thin, the way winter afternoon light sometimes falls across a room through a small window, enough to see by, enough to feel the faintest warmth of, but not enough to fill the space entirely. The shadows here would be long and soft. The world would feel, always, like the last hour before dusk. Neptune has winds. This is one of the things that surprises people when they first learn it. because it seems somehow counterintuitive that a world so far from the sun, so cold, so remote, could have weather at all. And yet it does, in fact. Neptune has some of the most sustained winds in the solar system. Great streams of atmosphere moving at speeds that would be difficult to comprehend from the ground. But even knowing this, it does not feel right to call Neptune a violent place. The winds are simply part of what Neptune is. The way a river is simply part of what a valley is. They move because that is what they do. They have been moving for longer than our species has existed, and they will continue moving long after. There is something almost meditative in that. A process so large and so old that the word storm feels too small and too urgent for it. It is more like breathing. It is more like the slow circulation of something vast and patient, turning itself over in the cold. Imagine the texture of Neptune's clouds. If you could somehow drift among them, they would be made of ice crystals and frozen methane, and they would catch what little light there is and scatter it in pale, diffuse ways the way fog does on a quiet morning, softening everything, blurring the edges of things, making the world feel gentle and indistinct. There would be no hard lines here. Everything would shade gradually into everything else. The clouds into the sky into the dark into the deeper dark beyond. You might not even be able to say exactly where the atmosphere ended and space began. It would all simply fade, one thing into another with great patience and great calm. Neptune has moons, and the largest of them is called Triton. And Triton is one of the more quietly remarkable places in all the solar system. It orbits Neptune in the opposite direction from the planet's own rotation, moving against the current, so to speak, in a slow and stately retrograde path that takes it around Neptune roughly every 5.5 days. This backward orbit is one of the reasons scientists believe Triton was not born alongside Neptune, but came from somewhere else, drifting in from the outer regions of the solar system long ago, drawn in by Neptune's gravity, settling into its unusual path, and becoming in time as much a part of Neptune's story as if it had always been there. There is something quietly lovely about that, about a world finding its place through wandering, arriving from far away and staying. Triton's surface is cold in a way that is almost beyond ordinary imagining. The temperature there sits at something close to the coldest it is possible for a natural surface in our solar system to be. And yet even here, even in this profound and settled cold, things happen. There are geysers on Triton, gentle plumes of nitrogen gas that rise from beneath the surface when the thin sunlight warms the ice just enough, just barely enough to push something upward through the crust. These plumes rise perhaps 8 kilometers into the thin atmosphere before the wind catches them and carries them downwind in long, dark streaks across the pale surface. They are not dramatic, they are not violent. They are simply the world breathing, very slowly in the cold. They are Triton's way of being alive, in the particular quiet way that Triton is alive. The surface of Triton has been described as looking like the skin of a cantaloupe in some places, a texture of irregular rounded shapes pressed close together, formed by the slow cycling of ices over immense stretches of time. In other places it is smoother, covered in frozen nitrogen that reflects the faint sunlight back in pale, pinkish tones. If you could stand on Triton and look up, Neptune would fill a significant portion of the sky. hanging there in its deep blue, enormous and serene, and the sun would be a bright point of light. And everything else would be stars, more stars than you could count, sharp and steady in the airless dark above you. It would be very quiet. It would be the kind of quiet that has weight to it, the kind that you feel in your chest, in the slowing of your breath. And beyond Neptune, the solar system does not simply end. It softens, it becomes less defined. There is a region called the Kuiper Belt, a broad and diffuse scattering of icy objects that extends outward from Neptune's orbit, a kind of outer shore of the solar system, where small worlds and fragments of ancient ice drift in long, slow paths around the sun. Pluto lives here, reclassified now, but no less real, no less interesting for the change in its official name. Pluto has a heart, or something shaped like one, a vast pale plain of frozen nitrogen that sits on its surface in a shape that has delighted everyone who has seen the images. It has mountains of water ice. It has a thin atmosphere that rises and falls with the seasons of its very long year, a year that lasts nearly 250 Earth years. So that a single season on Pluto is something like a human lifetime. The light on Pluto is very dim, dimmer even than Neptune, and the sun from there is just a star. The brightest star, but a star. The sky would be dark even at midday. The colors of Pluto's surface are soft and reddish and golden in places, the result of complex organic molecules forming slowly in the thin atmosphere, settling onto the ice, building up over time into something that colors the world in warm, muted tones. It is a cold world that looks, in its way, almost warm. There is something comforting in that small contradiction. A world dressed in the colors of autumn leaves and old wood, sitting quietly at the edge of the solar system, turning slowly in the near dark. Beyond the Kuiper Belt, there is thought to be another region. More distant still, a vast spherical cloud of icy bodies that surrounds the entire solar system at an enormous remove. It is called the Oort cloud, and it has never been directly observed, but its existence is inferred from the long-period comets that occasionally drift inward toward the sun, travelers from the very outermost reaches, following paths that take them millions of years to complete. The Oort cloud, if it is there as the models suggest, is the true outer boundary of the sun's gravitational influence, the place where the sun's pull finally fades to something indistinguishable from the general pull of the galaxy itself. It is the last room in the house. It is the place where the garden becomes the field, and the field becomes the horizon, and the horizon becomes the sky. We have been traveling a long way together. In this quiet tour, we began close to the sun, in the heat and the brightness, where Mercury sits in its slow, ancient rotation and Venus wraps itself in its warm, dense clouds. We passed through the familiar territory of Earth, with its blue water and its moving air, and we visited Mars in its rust-colored stillness, and we drifted through the asteroid belt where small worlds turn in patient orbits. We spent time with Jupiter and its great, slow storms, and Saturn with its rings catching the light like something from a dream, and Uranus tilted on its side in its long, quiet journey, and Neptune in its deep blue cold. And now we are here, at the edge where the solar system breathes out into the wider dark of the galaxy. And there is a feeling of having come a very long way, and of the journey being, in its own gentle way, complete. The solar system is very large and very old. It formed from a cloud of gas and dust roughly 4.5 billion years ago. A slow process of gathering and settling, of gravity pulling things together, of heat and pressure building at the center until the sun ignited and began to shine. The planets formed from what was left over, small particles sticking together, growing larger, sweeping their orbits clear over millions of years, becoming the worlds we have been visiting. The whole process was unhurried, as these things always are when they are working on the scale of geology and astronomy, where time is measured not in years or centuries, but in eons, in spans so long that the imagination softens at the edges trying to hold them. And here we all are, on one of those worlds, the third one out from the sun, sitting with our small fires and our warm drinks, looking up at the night sky and seeing the other worlds as points of light, as wanderers among the fixed stars, as places that are real and present even when they seem impossibly remote. There is something deeply settling about that, about knowing that the solar system is there. All of it always, the planets moving in their orbits, the moons following their paths, the ice and the rock and the gas and the dust all turning slowly in the dark, following the same rules, obeying the same quiet physics, going about the long business of being worlds. Somewhere out there tonight, Jupiter's cloud bands are moving in their slow, enormous currents. Saturn's rings are catching the light of the distant sun. On Titan, it may be raining methane into lakes of methane on a surface of water ice. On Europa, beneath its cracked and frozen shell, an ocean of liquid water is moving in the dark. On Mars, a thin wind is pushing a little dust across a red plain under a butterscotch sky. And the sun is shining on all of it, or trying to, sending its light outward in every direction. The light taking 8 minutes to reach us here on Earth, 40 minutes to reach Jupiter, more than 4 hours to reach Neptune, and still going, still traveling, out past Pluto, out past the Kuiper Belt, out into the Oort cloud and beyond, until it finally fades into the general light of the galaxy, indistinguishable from the light of all the other stars. We are part of this. That is perhaps the most quietly remarkable thing of all. The same elements that make up the sun and the planets, the carbon and the oxygen and the iron and the silicon, are the elements that make up us, assembled differently, arranged into the particular and improbable shapes of living things, of thinking things, of things that can lie still in the dark and listen to a slow story about the solar system and feel, in some wordless way, that they are being told something about themselves. We are made of the same old dust. We are part of the same long story. And tonight, right now, we are resting, as all things rest in the turning of the world, in the moving of the air, in the soft and steady dark. Let the solar system go on without you for a while. Let Jupiter's storms turn. Let Saturn's rings catch whatever light they catch. Let Neptune breathe its slow, cold winds. Let Triton's geysers rise and fall in the thin atmosphere, leaving their dark streaks on the pale ice. All of it will be there when you return to it. All of it is patient. All of it has time. For now, there is only this: the warmth of wherever you are, the weight of your body settling, the breath coming slower, the thoughts loosening their hold, the way thoughts do when the mind begins to let go of the day and drift toward the deeper quiet. The solar system is very large and very old and very calm. And you are a small and temporary and entirely welcome part of it. And tonight you can rest in that. And let the dark be dark. And let the quiet be quiet. And let yourself go gently, gently into the long and easy dark.